What's up guys, it's week 3 of filming what I do in a week, and this week I want to start a little side project. So it's been a few months since I made my last kind of robotic thing, and I wanted to get back into it with making some sort of drawing robot. I tried doing one of these things about a year ago and it ended up working pretty bad, so I'm gonna try it again, and this time I'm gonna follow this tutorial. This thing here is made by Make Magazine. Go check them out, they got a bunch of cool stuff. But I found this article here on how to learn inverse kinematics with a robotic arm DrawBot. Now this design is a little bit different from the first drawing robot that I made. However, I think it's a little bit better actually, and it looks like they've got all of the CAD files here along with the code. Oh, here's all the math that goes with it. Codes right here. And yeah, it doesn't look super hard, so I definitely want to give it a shot. We're gonna have to make our own CAD files though, since I don't have the right servos for this, but that's fine. I got an idea for how we're gonna do those really simply. Now to start this off, I think we should start by getting the components that we need for it. Over here, I've been slowly building up my collection of robotics or just electronic stuff in general. And I've got this whole bin here full of sensors, all sorts of things. And I believe my servos are in here, so we gotta go pull those out. All right, so we got my two main electronics boxes right here. This thing's got batteries, ESP32s, I think. What are these? Here's our servos, so we're gonna need those. I guess I thought they were in here, but I guess not. Now they're using an Arduino to control this, but I'm just gonna use an ESP32. The coding and everything should be the same. And then for the arms, we're gonna use these little skateboard bearings right here that I got. But yeah, I believe that's all we're gonna need for this. So we can put all this stuff back. Ooh, actually we might need these. All right, so we've got all of our components here. We got our servos, little just connector things, our ESP32, and then our bearings. I believe that's all we're gonna need. Oh wait, we don't need it right now. I think the tutorial does use a little joystick to control it, but I'm gonna see if we can just input points in my computer. So I don't think we're gonna need that right now. Now that we've gotten all of our components right here, I'm gonna start moving these things into CAD so that we can design the arms and the little mount thing that holds the pen and all that stuff. All right guys, it's the next day. I went ahead and got this thing printed and assembled. I did have to do a small design tweak on the servo shell right here and then reprint that. But besides that, this thing's looking absolutely awesome. I definitely think it looks a whole lot better than the first one I made a year ago. Now the only problem I see right now is that there is quite a bit of backlash right here. And I believe that's because I'm using cheap servo motors, and I also designed these little arms right here so that they just connect really easily. And it looks like there is a little bit of wiggle room in there, so is what it is. As you can see right here, super simple. I just used one of these like laundry clip things, and you can just easily pop in your pen or marker or whatever. These things aren't actually attached here. It's just whatever marker you have in there. So pretty simple design, but now what we got to do is get this thing wired up and then try to figure out how we're going to code this thing. All right, so we got the robot here on my desk. I've also got the article pulled up right here, and it looks like the next thing we got to do is figure out the inverse kinematics. So this is our robot arm crab. A squared plus B squared equals C squared. Finding the value. Okay, so interesting. So like that, we can get these angles. Okay, so we've got all of the math figured out. I understand it for the most part. Some things I don't know why they're doing it that way, but we'll figure that out later. I just want to see this thing work. Servo pins. New sketch opened up. And then power to power, ground, boom. I believe they use a joystick to control this. Joystick right there. And, oh, okay, we bent some pins. To the center point of that, then the center point of that, to the center point of this, we're gonna have to use U. Okay, we could copy and paste this whole thing into code, but I don't really wanna do that. I wanna just type it out and see how it goes here. So we're gonna have to make some modifications anyways. Now I think link 1, I think that's their L1. Yeah, that makes sense. D minus X twice? Oh yeah, because it's a, whatever. -1, that's interesting. I thought it was -2. I think we might wanna add a delay here. Just a quick one, 10 milliseconds. DrawBot V2. Okay, 2 more errors. Break it down here. Oh, I just had a capital K there. Okay, nothing's changing on the serial monitor, which is really weird. Okay, maybe it's our joystick. Let me get another one. This one doesn't work either. It must be something with the wiring. I do something wrong. Dude, okay, what the heck is up with this crap? If X val is less than 800, so we're just gonna take away 5. Nan and nan. What does that mean? All right, so I'm gonna try debugging this here. It's gonna take me a second probably. I'll see you guys when I get somewhere. All right guys, it's a few hours later and I got something that kind of works. I had to swap out the joysticks because for some reason they were screwed up. I haven't put on the arms yet, so we're gonna give that a try right now. Not a big fan of how there's like no space on this table, but it is what it is. All right, let's give it a try now. Oh, that's perfect, it moved down. Let's move it up. Oh! Holy cow, hold up. Oh my goodness. Hold up, I gotta bring this to the table and try it with some paper or something. Okay, we've got the robot here. Now, the connections are so bad, it doesn't really work too well, but hold up, John. Here, move your hand. Okay, so what I'm gonna do is reset the location. Location's reset. We're gonna pop in a kinda new paper. We're gonna have to mount it down. Here we go, you ready? You ready for this? We're gonna move straight down. I went back up for some reason. I don't know why. For some reason, when you go too far down, it like resets the values or something, or the servos change. I'm not sure what the heck's the deal here. Anyways, that's straight up and down. That's what I see there. So we do have a kind of straight line, which that's pretty neat. Now, I find that this one works best. Let's go left and right. Oh my goodness, I just said that and it didn't work. Okay. I find this works best and it just craps. Dude, okay, look at that. That's a straight up 90-degree angle right there. Here, let me draw a little bit more. What the heck is going on? Why are we drawing like that now? Okay, right there. That's a straight up 90-degree angle. Dude, we went straight up and down. That's pretty good. That shows that the math is working. We just have a crappy rig. And so I think we need to upgrade this a little bit. All right, guys, so it's the next day. We just saw yesterday that this thing does actually seem to work. It is a little bit janky just because of the cheap servos that I have and the overall design. Like I said earlier, this thing does have quite a bit of backlash. And that's why it's not able to draw super straight lines. But that was a good test. At least we got the math end of things figured out. As a matter of fact, I went ahead today and did some more testing with the inverse kinematics here just to see if I could understand it a little bit better. And I now think I have a pretty good understanding of how all of that math stuff works. However, I want to get this thing to be even more precise. And so that's why I'm going to swap out our servos with these. These are stepper motors. They're way more precise and a lot stronger than these little servos right here. And what I want to do is swap out the servos with these. And then of course we'll have to go and update the code, but it should be a whole lot smoother. So the first thing we got to do is get some of these stepper motors, and I have 2 that are inside my smart shelf thing right here. And I kind of want to pull them out and reuse them for this project. So let's see how this goes. Oh crap, oh crap. Okay, hold up. Oh, I'm gonna do these wires. All right, microphone fell off, but we should be good now. The whole thing is down. I think I'm just gonna take this stuff out here too because I want to maybe use it in somewhere else. The wires. Oh, that's my motor. Motor nearly came and hit me in the head. All right, so we've now got 2 of these stepper motors right here. There are these little belt drive gear things on here, and so we're gonna have to figure out how to get those off. We also got a power supply from that. I didn't think we were gonna need a power supply at first, but then I realized you probably are, so I just got this anyways. I probably ain't gonna use this one, but we got it out of there. So what we gotta do now is figure out how to pull off these little gear things. All right, guys, we got both of the little gears off of the motors right here. These were a little bit harder to get off than I expected, so I actually had to go ask my dad to see if he had a special tool for it, and he didn't. So we actually just tried prying them off, and that worked for one of them, but the second one was a little bit harder, and we actually ended up bending the shaft. And so we just took it apart, and it actually looks pretty cool, the inside here. But luckily, I did find another motor inside my box that was the same size and everything, so that's good. Now what we've got to do is just take these, move them into CAD, and then get our new arm design. Where is it? And then get our new arm designed and printed. So let's do that. All right, guys, it's the next day. The robot is now wired up and I'm now ready to start programming this thing. I already have most of the complex stuff, I guess, solved in Python, but what I need to do now is convert that over to C++ and get it so that we can run it on this ESP32 right here. So to start things off, let's figure out how we're gonna home this thing. I was just gonna go do some coding and I turned on this thing here so that I could have the over-the-air updates active so that when I'm ready to send the code, it'd be all ready. But then I stepped out of my room and I noticed like there was this weird smoke smell. And then I come back in here and my whole room smells like smoke and something was burning up. These motors are extremely hot. Like it was so hot, this thing here, which was tight on there, slid off super easy. It smells extremely terrible. I gotta open a door or something and turn on filter. Okay, I don't know what's going on, but we might have just ruined two good motors right here. We're just gonna turn it on and off real quick. Okay, that one still locks up. Let's see, are we having too much power going to them? Dude, these are so hot though. The wires are not too hot, which is surprising. Oh, geez. All right, well, I'm gonna go do some research and figure out what the heck's going on here. All right, guys, I believe I found the problem, and I think it was I was just putting too much current into each motor. These drivers here allow you to select how much current goes into each motor right here. And basically, I had them on an old setting for a different project that used a lot bigger stepper motors. And I was putting in like double the amount of current that these things actually required. And so I think that's why they got so hot. Hopefully they're not too bad. This one was actually fused to the plastic here, so I had to kind of pry it apart. So yeah, they might be ruined, but it is what it is. I think they still work though. They just probably aren't as efficient as they was before. I know this whole mess right here is not ideal, but it's all right. Anyways, I also went and connected up the enable pin right here. That way we can turn these motors off and on. So right now, even though there's electricity in the system, the motors are off and they're not actually taking up any power. So we shouldn't have an overheating problem again. I also went and wrote up a little test sketch right here to test the homing of the arms. So what we're gonna do is send that over right now. Okay, it's set, it should be. What's going on here? Oh, hey, that one worked. All right, so maybe this motor is totally broken. All right, so I have another motor right here. This one is slightly bigger, but it should use the same power rating. And so what we're gonna do is just unplug this and plug it into this one. Oh, this one isn't moving either. So it's probably not a motor problem, it's probably a code problem. All right, so I'm gonna go check the code for this now, but that's really exciting that we got this first motor to move right here, or the second motor to move right here. Ideally, what they should both do is go boom like that, and then boom like that. Then we know the angles that each of these are at, and then we can start sending the other inverse kinematic equations to them. Well, let's try to figure out what's wrong with this. All right, test number 2, I think I have it fixed. Holy cow. Well, this motor just might be fried. Interesting. All right, new motor test. Here we go. Perfect. Dude, that's sick. All right, guys, I'm sending the next update to the ESP32 right now. It should home, and then it should move back out to a certain position. Here we go. Okay, homing. Okay. And scene 2 quit. What the heck's going on here? Well, let's give it another shot. Let's just turn it off and turn it back on again. Okay, homing. Boom. What's the deal here? Let me check the code real quick. All right, I figured out the problem. It was actually super simple, but now if we go like this, it will start up and then it will home. It will home. Are you kidding me? Quit working as soon as I start talking. Okay, maybe we need to... Oh, what the heck? Okay, it's doing it here. Maybe there was a loose wire or something. Let's make sure all these connections are good. Okay, it's homed. Now it's going to a certain position. And then this will be the starting position. Now, if we turn it off right here, we can see that there is a problem, and I believe this is just a problem with the design. It's when it goes in like this to home. This thing here, for some reason, has a lot of play in it. A lot more play than when it's out here. So I don't believe it's the pen setup. I believe it's with how it's designed, kinda. There's a lot of play here, and sometimes if it goes too far back, then these will try to move out and it'll get caught back here. So what I'm gonna do right now is just tape our old leg right here, so that way it can't go all the way back, but it can still home. We're gonna have to fix that for version 4, I guess. But yeah, that's kind of a problem. Let's see it do it one more time. And this is taking way too long to start up the homing sequence. Maybe it's an internet problem. What we need to do now is get these buttons here set up so that we can adjust the coordinates and then have it auto update and then move the pencil around or pen around. So let's try to figure that out. All right, button test 1. Here we go. Okay. Nothing. Oh, hold up. I forgot something in the code. All right, test number 2. All right. Oh. Dude, that's dope. Oh, crap, just drew on my board. Oh, okay, so this is the exact problem right here. It gets caught. That was just what I was talking about earlier. Now with this, I have it adjusted to 2 millimeters, so. Okay, it's definitely moving slower. Okay, I'm gonna adjust it to 1 millimeter, and then I'm also gonna turn up the speed on these things. Okay, I turned up the speed, and I also adjusted it to 1 millimeter, so it should be faster on this going to the first point here. A little bit faster, okay. Hey, at least it looks like they're both moving at the same time, even though they technically aren't. Okay, I think it's my delay. I'm gonna adjust my delay real quick. Okay, the delay is adjusted, and so let's check it out here. Let's start by going down. Okay, so it's definitely faster. It's still just, what the heck happened? Oh, I think it went into a zone where it couldn't go any further. Is that going? This one doesn't even look like it's moving. When it goes down, this thing doesn't even look like it's, oh no, it is. Now it's going back up. Okay, hold up. So maybe there's something in the inverse kinematics equations because the servo did this as well. If we recall back to this one here, I remember there being some sort of problem that when you press the down or up button too much or whatever, it would go down and then it would start going back up. But it looks like that problem's translated over to this one as well. And if that's the case, then that's an inverse kinematics problem. But it does look like it's going in a straight line. At least to me it does. We're gonna have to move it to a table. All right, guys, it's Thursday. It was actually getting a little too late last night and it was kind of too dark to show this thing drawing. However, I did go and make a few changes, starting with making it move both the motors at the same time. Now, it isn't actually moving both the motors at the same time, but it looks like it, and it actually makes it a little bit smoother. I also went and added in some shapes for it to draw. For example, we just pressed this one button right here and it should draw a square. Now, it isn't really the best square, it's more of a rectangle really, but it kind of gets it. Now, like before, you still have the button controls, so I can still go up or down left, right. Actually, let's try to draw a square. Oh, whoops. Oh, that's pretty close. That's pretty close. Let's see if we can draw like a... Actually, we can't with this setup. Oh, okay, so that's a problem. Now, for some reason, this setup has a few problems, and I think it has something to do with the math. As we just saw, I went a little too far to the right or up, and for some reason, it clocks the arm back, and then it gets caught in this loop of spinning the motor out. When that happens, I just have to turn it off and turn it back on again. Despite that, though, I also went and added in a few other shapes. For example, we have a triangle right here, a hexagon, and that's about it. One thing I did notice though is that it slightly drifts to one side when it's drawing something. For example, I had it run on a loop here where it just kept drawing a rectangle. And for some reason you can see it slowly turn down to the bottom right. It makes for these kind of cool looking little pictures right here, but it's not really ideal. As we can see, it's following a clear curvature right here, so there is definitely something up with the actual arm. Maybe the picture is too far out or something, but I'm not entirely sure. Now, while this thing does have a few problems, I definitely think it's a big upgrade from the first robot that I made like a year ago. That thing didn't really draw at all, and there was way more bugs in that one than there is in this one. But as you can see, this one is still not perfect yet, and there's quite a bit of room for us to improve on right here. The first thing that I want to change up with the next version is the actual design of it. Like I mentioned earlier, the pen can actually swing too far back and then get caught during the homing stage, which causes it to not be in the right place when it goes to the starting point. So we got to do something about that. I also might try adding magnetic encoders. They would just help out with actually reading the right angle that the motor is at. Right now I have it set up off of counting the steps that the motor is taking, and I did that just because I didn't want to deal with any magnetic encoders, but magnetic encoders would be a little bit more precise. We also need to add a thing called linear interpolation. Basically what this does is it takes in 2 points and then generates a bunch of points in between those points. That way we can actually draw a straighter line. Right now, like with the triangle and stuff, the end effector or pen is going from one point to the other, and since it has to spin one motor at a time, that means that one motor might get to its angle before the other motor does, which causes it to make like this weird arc. It technically does still get to the right point. However, the line that it drew to get there is really wobbly and stuff. And so what I think we do is just add a bunch of little points in between those two main points. And then we get to those little points in between, and it makes the whole line look a lot straighter. Now, I'm not 100% sure if that's what we need to do, but I think that's what we need to do. And so I'm gonna see if I can add that in for next week's version. And I am gonna continue to upgrade this. However, if you guys wanna build this for yourself, I am gonna leave a materials list along with all the code and all of the CAD files or STL files for this in the description below. Hold up, there's a spider right there. I tried getting this guy and he fell down. Okay, here we go. Did I get him? Oh my gosh, he got away again. Hold up, hold up. Oh, I got him. Oh my goodness. Jeez. All right, sorry about that. I just saw that spider earlier and I missed him, and so I had to get him right now. Anyways, I will be leaving all the files to this thing in the description below, so go check that out if you guys want to build this for yourself. There isn't a wiring diagram or anything. I just came up with this on the spot, and this whole setup is definitely not ideal. Also, one thing I want to be changing in version 4 is maybe the wiring situation. This whole thing is a mess right now, and so I kind of want to develop a little case or something to put this in and make it a little bit cleaner. But yeah, we first need to get an efficient robot though. Anyways, I hope you guys enjoyed today's video. If you guys want to see more videos like this, make sure you hit the like button and maybe even subscribe button if you want to. If you have any ideas for projects I should build, leave them in the comments below and I'll see what I can do. But with that, I'll see you guys all next week.